Lakes, another surface water supply. And now what we have is a giant reservoir effectively. But again, if we pump lakes too low during the summer, then we have the recreation people screaming at us. You know, there's a lot of people that live around a lake. A lake is a very popular thing to have. Properties around a lake are very expensive. Recreation around a lake is the most valuable resource to most people. They're not trying to make a living from it. They're trying to enjoy and use nature. And you don't take that from people. They think that's an inherent right. And I can't say I disagree. I think that's part of the quality of life in any area, is that you maintain those entities that make that area attractive and enjoyable to live in. So there becomes a balance of nature versus utility of water supply. And the utility would be irrigated farming. And so again, there is a balance in a lot of areas where they will say, okay, you can irrigate to the point where the water level in the lake reaches a certain elevation. Then we have to back off or shut off. And so they're controlling the use according to the drawdown in the lake. Now, to counter most of this, what they do is they go in and develop reservoirs, side storages, artificial lakes, so that we can store that water that's coming during the peak runoff, hold it in place, don't let it go anywhere, and then when the rivers start to diminish flows, then start releasing the water out of the reservoir into the stream, so that you maintain a constant or near constant flow in the stream throughout the season, so that you have a continuous water supply available at a given flow rate. Now you can see the problems that can arise in a reservoir. First of all, we got to know how much water we're storing. You know, what is its capacity? And we have to know how good the quality of that water is. The quality is going to account a couple of ways: silt load and salt load. Both are bad deals. And silt load will eventually fill up the reservoir. We put a lot of silted water into a reservoir, it's going to sit there for 2 or 3 months. What happens to the silt? Settles right to the bottom. All of a sudden the reservoir just shrunk because we just put a layer of silt in the bottom and we lost so much depth in the reservoir. And you do that year after year after year after year. Over time, eventually, you're going to lose all your capacity in that reservoir, unless you have a way of flushing it out on the discharge side or going in and dredging it in the off season. So those are a couple of options you have. But those things you have to know about. And then salted, you know, how bad is the salt content? Is it so highly salted that it's not going to be a usable supply? Something that has to be looked at. Another thing you have to calculate is evaporation off that reservoir. During the time it's sitting in that reservoir, how much are you going to lose to evaporation? Some of that's going to disappear on you. You know, you get into the heat of summer, you lose a ½ an inch of water a day. When you got a 105-degree day out there, that's a lot of water off. You know, if you got a reservoir that's a few square miles in surface area, that's a lot of water taken off of there every day. That's why we cover our swimming pools, so we don't lose all the water out of them. Well, those of us, I don't have a swimming pool, don't know about that, but my neighbor does. And it also keeps them warm, but man, you'd be putting a lot of water in a pool every day if you didn't have it covered. And it isn't because it's getting splashed out. It's evaporating out. It's just lost, you know, it's water lost. You have to know how much you can discharge out of that reservoir. You have to develop the right kind of spillway so that you have ample discharge capabilities. So if you need to take X number of cubic feet a minute out of that reservoir, you have to have it designed to do that. And then you really got to be concerned about whether or not you have a seepage problem under that reservoir. How much are you losing? How much is percolating out underneath it and getting into the underground aquifers, or coming around and popping up on the other side of it somewhere? And a classic example of that is Bennington Lake. We got this big earthen dam across in a canyon, and they fill that thing up with water. Well, they thought they had a real nice basalt underlayment, and they had this dam built so that it wouldn't leak. Wrong. There's all kinds of fractures in that basalt, and they put enough hydraulic pressure, in other words, they get the water high enough in that reservoir, it starts seeping down through the cracks in the basalt, and it pops up in people's basements all over Walla Walla. And the town just gets in a major snit, as you might expect, especially if you had a basement that was getting filled with water. And little springs break up places that people never knew they existed in their yards. You know, all of a sudden, oh, there's water. Pops out of the ground. There's got a puddle sitting there. And it happens. I mean, that is just what happens. Now, there are solutions to that, and the solution to this reservoir is about a $2 million liner. They're going to put a giant plastic liner underneath that thing so water can't flow down underneath it. And someday that could happen. That could First of all, they tried drilling holes down into the basalt and then pumping grout, this kind of stuff, this mortar. They tried forcing mortar down into the seams and hoping they would seal up the cracks in the basalt. Spent a minor fortune doing that. Didn't work. Didn't work. Still was having the problem.